colorful triangle. Should I restart? Anyway, basically what I said is that there's centroid division is like a clear indicator that we should extend this over the midpoint of AC to get a parallelogram. And this is generally very useful in practice. There's another method, which is basically you can bash using the median thing, which is like Stewart's theorem or something like that. Anyways, let me just going to go over this one. After you get this parallelogram, the 6 colorful triangles have the same area. And this length is 13. Let's just say 13, and then this one's 14, this one's 15. So let's say this blue triangle. The blue triangle has all of this length, 2/3 of 13, 14, and 15. So the area of the blue triangle is 4/9, or basically 2/3 squared of the area of the triangle formed by 13, 14, 15, which is sort of well known to be 84. And then after you do that, you get 6 times this number, which is like 24/9. Wait, not 24/9. 4/3. Yeah, 4/3. That's what it is. 4/3 of 84. Wait, I think I messed something up. No, I think it's fine. This is like one blue thing. This is like 6 times this thing, but we counted this triangle twice. So you do half of this. That's 4/3 of 84, which is 112. That's the answer. Any questions with this first one? Should be easy point. Okay, I guess there's no questions about this one. Does Yichen or Justin have any comments about this geometry problem? Like what, like comments or like ideas this can spark? Like this is a basic problem, but like it has like some ideas behind it. It's pretty useful in like generally in most problems. Okay, guess not. I'm just going to go over the next question, which is like a very basic concept of mod, like somewhat like related to like bases, like base 2, base 3, and stuff like that. Let me just put this aside. I'm going to go over the second question. So here we have n equals to this thing with digits, and we let fn to be this strange like reverted base thing. So it's like sort of like you can, if you think of bases like how they usually be like the sum of like 10 to the power of something times a number between 0 and 9 for base 10, we can extend this to base like of rational numbers and stuff like that. And this awfully looks like the base half, like just for extension. And so this is like a0 times, like this is 10 to the power of n plus, oops, what was that? What? Something happened. Never mind. 10 to the power of n plus like 10 to the power of n minus 1, an minus 1, and stuff like that. Something happened again. I'm just going to write like over here. It's like n is equal to 10 to the power of n 10 to the power of n minus 1, an minus 1. It's a bunch. And fn, in this generalized idea, after we divide, we can factor out 2 to the power of n, and it turns out to be half of n to the an plus half n minus 1, and all that. So like this is like a generalized concept like base half, perhaps. But like base half isn't the real thing. So like we want to establish some connection between n and fn. So the main idea is to establish a relationship between 10 and half. Like, so this is our first observation over here. This may or may not be useful later, but here's our like first observation. It's fine if you don't get this observation. I'm just giving like a broad comment about what this thing could be like represented as. But perhaps a more natural attempt to solve this problem is that this number is a lot smaller than n. Like n is like 10 to the power of n an, and this is like just one of these an. So we naturally want to compare the sizes of this thing. Like this is like really small and that's huge. And there are a lot of iterations of this, so it's probably going to get a lot smaller. So you expect the answer to be like at most like a 3-digit number or 2-digit number, or perhaps even a 1-digit number. So let's just inspect this f thing. Let's say n is that number, like this thing. And fn is defined like that way as well. So first we look at fn is obviously, if we maximize every single number to be 9, it's obviously less than 2 to the power of 9 times 2 to the power of n, 9 times 2 to the power of n minus 1 until it's 9. That's just 9 to the power, 9 times this thing. And that is 99.99% chance that this is less than 10 to the power of n. And this holds if n is at least 3. I think you can just check this by like induction or whatever. This should be pretty easy. When n is 2, you can sort of like, it's pretty easy. It's just literally 2 numbers. And we just blah, 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 we get it's 19. 19 is the only 2-digit number that after doing f, it remains as 19 and does not get smaller. If it's a 1-digit number, obviously it's going to remain as the same 1-digit number. So we know the answer is 1 of 1, 2, 3, 4, 5, 6, 7, 8, 9, or 19. Obviously it's not 0. So like this like sparks the idea, like 19 and like this 10 and half. It's like sort of gives the idea of mod 19. It's not super obvious, but perhaps this analogy would work. If you divide something by 9, like if I wanted to find the divisibility rules of 1431, then I would just add the digits up. That's like basically looking at the number in base 1. So these are like the congruent mod 9, because 10 and 1 are congruent mod 9. Perhaps that's one approach to look at it. This will be base half. So like I'm looking at 10 is congruent to half in what base? Maybe I'm extending this too much, but this is 19. So perhaps from here, it's a good way to solve the problem, or like just mod arbitrary numbers perhaps. Anyway, this 19 is pretty strong signal. So we mod 19 and we figure out from here, or from a more general way, like you just multiply 10 to the power of n onto this thing. You can just do like whatever. They can multiply 2 to the power of n on this thing. There's many ways to do it, but n and fn should be congruent. And if 19 is divisible by n, then 19 should be divisible by f of n. You can do this by like guess and check or whatever, this thing. And then after that, you can get that the answer must be 19 because none of the other numbers from 1 through 9 are divisible by 19. So the number must be 19. Yeah. Perhaps I can just fill out the details of this one. You just write it like here. So if fn is 2 to the power of n a0 plus 2 to the power of n minus 1 a1 plus an, then we multiply the whole thing by 10 to the power of n. This is 20 to the power of n a0 plus 20 to the power of n minus 1 times 10 a1 plus 20 to the power of n minus 2 times 100 or 10 squared a2 plus you can write 10 to the power of 0. Wait, not 10 to the 20 to the power of 0. 10n an. This is all the 20s congruent to 19, congruent to 119, so we just ignore these. So this is congruent to n mod 19. So therefore, if 19 divides n, 19 divides fn. So that's how you solve the problem. Like this is part 1, the nt part, and this is like the very obvious inequality part. Yeah. What does space mean? Yeah, for the first one, I said the area of a triangle with side lengths 13, 14, 15 is well known because you can just use like whatever, the square root of semi-perimeter or something like that. And that's the area for this one. And then you can do this, or you can directly bash it. That's the other method. Like you can use the median length formula, which is like should be like simple. The median length formula is not extremely important. You can just use law of cosines to get it. I believe, not too sure, but I think the median length formula is this. I think I'm correct. Is that the median length formula? I think that's the median length formula. The answer for the first one is 112, and the answer for the second one is 19. Okay, any more questions? The best way to solve the first one is either by bashing or noticing this. The second one, a very natural way, like not extend that much. I just extended more when I was lecturing this. But a very natural way to solve this is to examine that f makes numbers smaller. We notice the 19, we mod 19. We notice like the 2 and 10, and like, we solved the problem. Because like, this is indeed a multiple of 19. This is not an arbitrary number. Yeah. Any more questions? Okay, no more questions. Let's hand it over to Yichen and solve for him to solve his own problems.
Oh, so question one was a geometry one. I have a graph
Oh,
here.
yeah, Yichen, let's let everyone follow you. Right now, everyone's still following Eric. Yeah.
Where's the button? Here,
Yeah, right.
right? Where's the button?
Mhm. Okay. So copy paste the problem and then you can present.
So this is a pretty big graph. I have the graph here that I drew. So if we like let this be what I'm talking about. So if we let this be A, this be B, and this be C, then this is gonna be P, and 6, 12, and 6 root 3. We see here like the length of a 36 90 right triangle, but like we're not sure how to use it or like combine them. So like we want to like somehow like get them into a 1 root 3 2 right triangle. So we do this by rotations, like we rotate triangle APB here to triangle AP prime C. So then once we rotate this, since it's equilateral, this like PAP will be 60 and B will match with C. So then we get that AP prime is 6 and P prime C is 12. Now it's equilateral here, so we get that P prime is also 6. And then this triangle is 30, 60, 90. So from this, we can calculate angles. So this would be a right angle, and this is 60 degrees, and so is this. So now we can use law of cosines on triangle AP prime C. So we get that AC squared equals 6 squared plus 12 squared minus 2ab cosine C, which is just going to be minus 2 times 6 times 16 times 120. So this is just equal to 36 plus 144 plus 72. So we get that AC is 6 root 7, not intentional. So that's the answer for this question. And this was a nice like showcase of how like you can use rotations in geometry to like help deal with like these right triangle lengths and make the question easier to solve. Wait, D prime? Do you mean D P prime? Like here, P prime is basically you rotate. I'll just write it here. Rotate triangle APB 60 degrees so that B lies on C. And then you can see like P goes here. Is that more clear? Okay, good. And now for problem two. Problem two, we can use complementary counting here. So basically for problem two, we can like calculate the chance that like she won't roll a 6 during these next n times. So let's do casework on n. So like let's say that she gets a 6 on the i's turn, which means that 6 on i's. Then that means that like the first I minus 1, I minus 1 are not 6, and next I are also not 6. So with this, we can use complementary counting and find the chance of this. So the chance of this is going to be 5/6 to the power of 2i minus 1, because we have I minus 1 and I that aren't 6, and then also times 1/6, because that's one that is 6, that's 1/6 chance of happening. And I starts from 1 here. So we have I is greater than or equal to 1. So then this this is just a sum of like sigma I equals 1 to infinity of 5/6 2i minus 1 times 1/6. And this just sums to 6/11 if you like use geometric sums or if you're a geometric series. Or this is 5/11ths, actually. So if we like sum this up, we get 5/11ths. And then this is a chance that like the next I will not contain a 6. So the chance that next I will contain a 6 is just 1 minus 5/11, which is 6/11. And that's this question. So this question was an example of like infinite geometric series in combinatorics and how you can like casework here to get an infinite geometric series, and you also use complementary counting to like solve for the answer. Any questions? I guess that's all then for these two questions. What?
Uh, Yichen, can you reopen the whiteboard, please?
Wait, I'm not sure where it is.
Did you close it?
No,
Hmm?
I think Eric left. Maybe that's why.
Okay, let me. Okay,
Or maybe it's back.
okay. So right now, Justin, yeah. Justin, it's your turn right now. Is Justin there? Oh, we cannot hear you, Justin. Hello? Hello, Justin, are you there? Hmm? Wait a second. Let me call Justin. Oh, wait a second. Hello, Justin, are you there? Oh, your mic is not working? Gosh. Uh, Hey, Eric, are you still there?
Yeah, my battery ran out. I'm recharging.
Oh, okay. Oh, Eric, Justin's microphone is not working. Is that possible? Can you present like the last two problems?
Yeah, I think it's possible.
Okay, thank you so much. So Justin, meanwhile, can you find another microphone?
Uh, Wait, I think it works now.
Oh, it works. Oh, that's great. That's great. Yeah.
Okay.
Oh, thank you, Eric. Thank you, Eric. Yeah, let Justin present. Yeah. So first, Justin, you need to copy paste the problems, the two problems you're gonna present. Yeah. And
Uh,
then let everybody follow you. It's on the top right corner. Hey, nobody writing on the screen, please. Hey, who is doing that?
uh,
It's on the top right corner.
uh,
You can choose, eyes on me. Because right now everybody's following me. You need to make sure that they follow you, right? Okay.
okay.
Then copy paste the problems. Do you have the problem?
I don't have a picture of it.
Let me do it. Wait a second. Let me do it. Let me find the
Let me
problem.
get it. Let me.
Uh, wait a second.
I found it.
Okay, so the first one was geometry.
Uh,
So we have uh wait,
Let me make it bigger for you. Okay. Okay. Yeah, that's working.
okay, so we have a triangle ABC. Okay, wait, I'll just use
Oh, Justin, you can like on the right on the toolbar, did you see the pencil, right?
yeah,
And you can choose the stroke style. You can make it like thicker, because right now
yeah,
it's too thin. It's hard for people to see it. Yeah.
okay.
Did you see this one? Stroke.
Yes,
Yeah,
I see it.
stroke thickness, right? Uh-huh.
So we have a triangle uh A, B, C, and the orthocenter is H. That's uh, the internal angle bisector of BAC intersects BC at Y, so this will be like that. Okay, so we have H equals AH equals 4, AY equals 6, and the distance from Y to AC is root 15, and we want to find BC. So the first thing you can do is let E be the foot from B to AC, so this is right angle. And then now we do some trigonometric manipulations. So we have 4 equals AH. This is given, which is equal to AE over sine of AHE, because right triangle AHE. And then from this, we notice that from right triangle ABE, AE is equal to AB cosine of BAC, which I'll just abbreviate as A. And then, okay, so from angle chasing, you can show that AHE is equal to this angle, which is 90 degrees minus this angle, which is uh, 90 minus C. So you can find that AHE is the same angle as C. So this will become sine C. and that. Okay, so now from the law of sines, we have AB over sine C equals 2R, where R is the circumradius of ABC. So this becomes, sine C becomes AB over 2R. So the entire expression becomes 2R cosine of A. Okay, so now we notice that cosine of A over 2 is equal to cosine of YAC, because Y is on the angle bisector of BAC. Okay, so now we notice that, let's just say this is G. So we have YG equals square root of 15, because that was given here, and AY equals 6. So from the Pythagorean theorem, we have AG equals square root of 21. And now from right triangle AYG, we have cosine of YAC equals square root 21 over 6. Okay, so now we recall the double angle formula for cosines, which states that cosine of A is equal to 2 times the cosine of A over 2 squared minus 1. So if you plug in root 21 over 6, you can find this to be 1/6. And from note that this is 4 equals 2R cosine A. So if we plug in cosine A equals 1/6, we find R equals 12. Additionally, since sine A squared plus cosine A squared equals 1, we have sine A equals root 35 over 6. And we know it's positive because A is between 0 degrees and 180 degrees. Okay, so now we use the law of sines one last time, and we have BC over sine A equals 2R. So we have BC equals 2 times R, which is 12 times root 35 over 6. And this is equal to 4 square root 35, which is the answer. R is the circumradius of triangle ABC. Any questions? Okay. Got it.
Okay, let's move on to the last problem. Yeah, Justin.
Okay, wait. Wait, how do I move the?
You
Oh, yeah.
just
Okay.
yeah, on the toolbar there's a arrow.
Right.
Yeah.
So,
Mhm.
wait, let me just move this here.
Mhm.
Okay, so given that 20 to the power of 22 plus 1 has exactly 4 prime divisors, P1 less than P2 less than P3 less than P4, determine P1 plus P2. Okay, so this is a number theory problem. So let's consider a prime P. I need to switch to. Okay, so let's assume a prime P divides 20 to the 22 plus 1. Yeah, so this means 20 to the power of 22 is equivalent to -1 mod p. And then this, if we square both sides, this becomes 20 to the 44 is equivalent to 1 mod p.
Sorry,
And
Justin, I have to pause you. Can you explain to those students because some of them not really like learn the modular, like how to solve a modular problem. Can you explain to them why the remainder here is -1? How did you get to this step? Like a 20 to the 22nd power, like a
Okay,
mod,
so
yeah.
all right, wait, let me
Oh, it's mod p, right? Oh, sorry, you're still explain the concept, right?
uh I guess yeah.
Oh, okay, sorry. Yes, just
Yeah.
continue. Yeah, please.
Okay, so we have this. So now we let D be the order of 20
You
mod
should
p.
explain what is order.
Yeah. Okay, so order is basically the least positive integers such that when a number is raised to that power, it becomes equivalent to 1 mod the okay, so I'll use an example. So 2 to the 1 is equivalent to 2 mod 3, and 2 squared is equivalent to 1. So the order of 2 mod 3 would be 2. Uh, so yeah, that's basically what order is. Uh, okay, so we let D be the order of 20 mod P. So then we have uh, D has to divide 44 because 20 to the 44 is equivalent to 1 mod P. So this, yeah. And we also require D does not divide 22 because if D did divide 22, then 20 to the power of 22 would be equivalent to 1 mod P, which it is not. Uh, um, okay, so P is, we see that P is not equal to 2 or 5 because, yeah. So since P is not equal to 2, 20 to the 22 cannot be equivalent to 1 mod P. So we need this. And if you look at the divisors of these numbers, we find that the only two possibilities for D are 4 or 44. Okay, so now we can look at these cases separately. So let me just do that. So let's do case 1, D equals 44. Okay, so by Fermat's little theorem, we have 20 to the p minus 1 is equivalent to 1 mod p. And now we need to have 44 divides p minus 1 by the definition of order. And the smallest p that satisfies this is 89, since 45 is not a prime. So we check p if p equals 89. So a lot of this problem is mostly just computation. So we have 2 to the 44 is equivalent to 2048 to the 4, because 2 to the 11 mod 89. And if you do the division, you'll find that 89 actually divides 2047. So this will just be equivalent to 1 to the 4, which is then equivalent to 1 mod 89. Okay, and now 5 to the 22 is equivalent to 5 squared times 5 to the power of 4 to the 5th power mod 89, which is 25 times 625 to the 5th power. And this 623 is divisible by 89. So this is 25 times 2 to the 5th power mod 89. And if you multiply this, this is 800, which is -1 mod 89. Okay, so the product of 2 to the 44 and 5 to the 22 is 20 to the 22. And if you multiply 1 and -1, you get -1 mod 89. So we have shown that this is what we want to prove, right? So we have shown that 89 does divide 20 to the power of 22 plus 1. So 89 does work. Okay. So the second case was d equals 4. So for d equals 4, we need to have 20 to the 4 is equivalent to 1 mod p, again by the definition of order. And then this is p divides 20 to the 4 minus 1. And with the difference of squares, you can factor this as 20 minus 1 times 20 plus 1 times 20 squared plus 1, which is equal to, so p divides 3 times 7 times 19 times 401. Okay, so you can manually check that if p is equal to 3, 7, or 19, then the order will be less than 4, and so it won't work. So that means the only possible case is p equals 401. So we will check that now. So 20 to the 22 is equivalent to 400 to the power of 11 mod 401, which is equivalent to -1 to the 11, which is then -1. So 401 also works. Yeah. Okay, so now it remains to show that there exists no p with p less than 401 and 44 divides p minus 1. So the reason for this is, if we look back, so in the case d equals 4, there was only one possibility for p, and that worked. But for d equals 44, we only checked the smallest value of p for 44 divides p minus 1. So we should go through all of them to make sure there's none less than 401. So you can find that the only primes with p less than 401 and 44 divides p minus 1 are 353 and 397. Okay, so if p equals 397, 20 to the 22 is equivalent to 400 to the 11, which is equivalent to the 3 to the 11 mod 397. And okay, so I'm not going to show the calculation, but you'll find that this is not equivalent to -1 mod 397. So that means 397 does not work. So we now move to p equals 353. Okay, so 2 to the 44 is equivalent to 2 to the 4 times 1024 to the 4 mod 353, which is equivalent to 2 to the 4 times negative 35 to the 4 mod, which is negative, which is 70 to the 4 mod 353. And this eventually becomes -1. Then if we calculate 5 to the 22, this is 5 squared times 625 to the 5 mod 353, which is 5 squared times negative 81 to the 5 mod 353. So it will take a bit of time, but you can also show that this is not 1 mod 353.
Justin, just make sure you make your 5 look like a 5, like, you know,
Yeah,
5. Yeah, this is a 622, 625 instead of 623, right? And
Yeah.
to the 5th power, right?
Yeah,
Yeah.
right.
Right.
Okay. Yeah. So after computation, you get this. And if you multiply these, you have 20 to the 22 is not equivalent to -1 mod 353. So we have shown that 353 does not work either, which means that 401 and 89 are the smallest primes that divide this. So since it asks for the sum of the two smallest prime divisors, the answer is 89 plus 401, which is 490.
Okay.
Yeah.
Okay. Thank you so much. Okay, I think this is the last problem. And thank you for, thank you for everyone, to join this session. And especially thanks to, thank Eric, Yichen, and Justin, spending time explaining those things, to you guys. And yeah, later, I think these problems today are moderate, like, I mean, the difficulty level. Maybe the last problem is a little bit hard, especially when the student who haven't learned the order, this concept. Yeah, later, when I send you guys the recordings, I will try to find some, articles or, YouTube video related to this concept to you guys, and probably you can learn from it. Okay. Yeah, let's call it a day. Okay. Thank you for joining this session. Yeah. Bye. And the next session will be October, I think 23rd, next Monday. Yeah. Bye. 27th, right? Bye.
By the way, I released the scores.
Yeah. Okay.
Bye.
Bye.